This skill training video has been produced by SEMCA in collaboration with PSSC and CNK. This video is aligned to the job role Electrician Domestic Solutions, PSS/Q6001, QP code PSS/N6001. We are now going to learn about types of heating element, thermal relays and insulation. Heating element converts electrical energy into heat through current flow. Electric current through the element encounters resistance, resulting in heating of the element. Heating elements are made of nichrome, kenthal, cupronickel, platinum, and so on. Thermal relay is a protector that uses the thermal effect of current to cut off or disconnect the circuit by bending the bimetallic strip. When the thermal relay is used for overload protection in the motor, it often works with AC contactor to form an electromagnetic starter. It is then used in the control and protection circuit of the single or three-phase motor. If the motor is overloaded for a longer period of time due to undervoltage or phase failure during operation, the current of the motor will exceed the rated value. At this time, the thermal breaker cuts off the control circuit of the motor, thus effectively protects the motor. Insulation prevents the formation of an electrical contact between parts of electrical or engineering equipment that are at differing potentials. Electrical insulation can be described in terms of electric strength, volume and surface resistance, dielectric loss, corona resistance, resistance to heat, cold and mechanical strength. Uses. Heating element is an electrically charged structure that is used to create heat in electric appliances to ensure that there is a greater control over the heating. Thermal overload relay is used in conjunction with a contactor to protect electric motors. The overload relay consists of inline bimetal strips connected to a set of contacts. Insulation is any material that prevents the passage of electricity, heat or sound from one area to another. Types of material used in heating element. 1. Nichrome. Nickel is equal to 80% plus chromium is equal to 20%. Properties of nichrome. 1. Resistivity 40 microohm centimeter. 2. Temperature coefficient of resistance 0.0004 per degree centigrade. 3. Melting point 1400 degree centigrade. 4. Specific gravity 8.4 gram per cubic centimeter. 5. High resistance to oxidation. Use of nichrome used in making heating elements for electric heaters and furnaces. 2. Kanthal. Kanthal is a trademark name for alloys made by composing iron, chromium, aluminium, FeCrAl. These alloys are used in wide range resistance and heating applications. Fe is equal to 62.5 to 76% plus Cr is equal to 20 to 30% plus Al is equal to 4 to 7.5%. Properties of Kanthal. 1. Resistivity at 20 degrees centigrade 145 microohm centimeter. 2. Temperature. Coefficient of resistance at 20 degrees centigrade 0.004 per degree centigrade. 3. Melting point 1500 degrees centigrade. 4. Specific gravity 7.10 gram per cubic centimeter. 5. High resistance to oxidation. Use of Kanthal. Used in making heating elements for electric heaters and furnaces. 3. Cupronickel. Cupronickel is also called as copper nickel. It is an alloy made by composing copper, nickel and strengthening elements such as iron and manganese. Cu is equal to 66% plus Ni is equal to 30% plus Fe is equal to 2% plus Mn is equal to 2%. Properties of cupronickel. 1. Resistivity at 20 degrees centigrade 50 microohm centimeter. 2. Temperature coefficient of resistance at 20 to 500 degree centigrade 0.00006 per degree centigrade. 3. Melting point 1280 degrees centigrade. 4. Specific gravity 8.86 gram per cubic centimeter. 5. High resistance to oxidation. Use of cupronickel. Used in making heating elements for electric heaters and furnaces for making coins. Thermal relays. As discussed earlier, thermal overload relay works on the principle of electrothermal properties in a bimetallic strip. The current flowing through the motor flows through the poles of the overload relay, OLR. The bimetallic strip gets heated up by the current directly or indirectly, and when the current flow exceeds a set value, it bends. Overload relays always work in combination with contactors. When the bimetallic strips heat up, the trip contact is activated. This in turn breaks the power supply to the contactor coil, de-energizing it and breaking the current flow to the motor. This tripping time is always inversely proportional to the current flow through the OLR. Hence, higher the current flow, faster the overload relay trips. Therefore, thermal overload relays are referred to as current dependent and inversely time delayed relays. Bimetallic strip. A bimetallic strip is used to convert a temperature change into mechanical displacement. The bimetallic strip consists of two strips of different metals which expand at different rates as they are heated, usually steel and copper, or in some cases steel and brass. The strips are joined together throughout their length by riveting, brazing, or welding. The different expansions force the flat strip to bend one way if heated, and in the opposite direction if cooled below its initial temperature. The sideways displacement of the strips is much larger than the small lengthways expansion in either of the two metals. This effect is used in a range of mechanical and electrical devices. In some applications, the bimetal strip is used in the flat form. In others, it is wrapped into a coil for compactness. Types of insulation. In electrical domestic work, the types of materials used for insulation are cable and wire insulation materials. Insulation is a non-conductive material or a material resistant to the flow of electric current. It prevents the wire's current from coming into contact with other conductors and preserves the material integrity of the wire by protecting against environmental threats such as water and heat. The safety and effectiveness of the wire depends on its insulation. Following are the different insulation materials and appliances in which it is used. Fiberglass ceiling. All heating elements such as microwave, toaster, induction plate, etc. Polyvinyl chloride, PVC sleeving, wires and cables. PVC heat shrinkable tubing, cable jointing. Bakelite sheets, electric paints, switches, contactors, connectors, etc. Ceramic paper, electric iron, oven, hot plate, etc. Mica sheet, electric iron, hair dryer, etc. Asbestos sheet, electric iron, hair dryer, etc. Heating element used in iron geysers and other electrical equipment, that is, thermostat. Thermostat is a device that keeps the temperature at the desired level by cutting off power supply once the desired temperature is achieved. As you are seeing in the iron where different temperature range given accordingly, it operates, and when temperature reaches at desired level, then it shuts off the iron. Slightly different from the air conditioner thermostat. The function of the thermostat in water heaters is to make sure that the water is heated till a particular temperature and thereafter the water heater needs to shut off. Thermostat keeps checking the temperature and switches the heater on again once the temperature decreases. The thermostat makes sure that the water is heated till the set temperature. As similar to geyser, many heating appliances such as electric furnace, electric oven, electric heaters and so on utilize the electrical energy to produce the heat. In these appliances, heating element is used to convert the electrical energy in the form of heat. The working of heating elements is based on heating effect of electric current. When a current is passed through a resistance, it produces heat.